All right, to close out the Lang.net 2006 Compiler Symposium, we have Bruce Payette talking about Windows PowerShell.
Thank you. As he said, my name is Bruce Payette. I'm a technical lead on the Windows PowerShell team. My lovely assistant, George, sitting over there. Wave, George. Hi, George. How are you? So
your mic is turned away.
Oh. How's that? Okay.
This is the master volume control.
Okay. Session objectives. What is PowerShell? Why did we do what we did? Why is it useful to admins, which is our primary target, but it's also good for developers? And why is PowerShell cool, for some definition of cool? And to put it a little bit in context, we're RC1 right now. We've been in beta for a distressingly long period of time. In that time, we've had somewhere between 80 and 100,000 downloads of PowerShell. On Microsoft Download Center, out of 20,000 downloads, we are the 218th most popular. And that's including things like Windows Media and stuff. So it's been very popular, which says something. So what is PowerShell? It is a modern, buzzword-compliant, command shell and late-bound dynamic scripting environment for Windows. That is, and this slide comes from Jeffrey Snover, who's the architect of the project. It is as interactive and composable as Bash or Corn Shell, as programmatic as Perl, Ruby. Python appears and disappears from this slide. I'm not entirely sure why. I think it's so we don't offend Jim. As production-oriented as the AS400 or DCL on VMS. Anybody know either of those environments? Yeah, right. So you understand what I mean by production-oriented. Very regular, very well specified, designed for production-oriented systems. And the last one's a little novel. We want to allow you to access data stores, any arbitrary data store on Windows as easily as accessing the file system. So kind of like /proc in Plan 9, 8th edition Unix, Linux, whatever. We want to, the file system metaphor is a very powerful and very compelling metaphor. We want to make this available in Windows. Talk a little bit about why, the business context for what we're doing. So we are in WEMD, the Weapons of Enterprise Mass Destruction, no, I'm sorry, Windows Enterprise Management Division. This is the group that does System Center Operations Manager, formerly MOM, SMS, which is the software distribution technology. That business, along with the other management technologies, is projected to be $1 billion all by itself, right? So this is not like all of server. This is like $1 billion just in management. And that's only a tiny segment because most of the money in the server management space goes to IBM Global Services or whatever, right? It goes to people because the tools suck. So the WMD as an organization is trying to fix that. PowerShell and then MMC. Anybody know what MMC is? Like three guys, yeah, management. Okay. So PowerShell is part of the same group, the Admin Experience Platform group. There's a larger effort going on in WMD called the Dynamic Systems Initiative. And it is trying to do model-based management, so creating schemas and information architecture for exporting management data across the enterprise. So you'll have some chance of doing organized management. Names matter, right? This used to be called Monad. And at MMS this year, we announced that we were shipping and that, oh yes, we've changed the name from Monad, which everybody loved, to PowerShell. And guess what day that was, right? The reaction to the name change was spectacular and not positive. Scott Hanselman did a blog, the 7 phases of coming to acceptance with a name change and so on. But although it's not a very remarkable name, it's actually a pretty good name because it describes what the product is. It describes powerful environment, but it is a shell, right? So I'm going to keep saying that over and over again. So why PowerShell, right? So you look at the stack of technologies that Microsoft offers to developers and admins, right? So we have Visual Studio, the other guys have Eclipse. We have .NET, they have Java, we have Python and Ruby, and now Iron Python and Iron Ruby. And thanks to Miguel and company, they have that too, right? We have NMake, they have GMake, we have MS Build, they have Ant. They have Corn Shell and Awk and Bash and Perl and Z Shell and all this other stuff, and we have, command.exe. We suck, right? So we actually commissioned a NerveWire study some number of years ago. That was the driver for this project. It basically said that command line management on Windows was unacceptably bad, and in a large environment, going clicky-clicky is good for one box, not so good for like 10,000 boxes. So that's the sort of the tool stack approach. This is a little different partitioning, right? So this is the programming stack. Who's read John Osterhout's paper explaining the difference between programming and scripting, right? So Gilad and Jim, because I know he cited it a couple of times. So John Osterhout, who was the creator of the Tickle scripting language, came to Sun at about the same time that Java was really coming up to speed. And people looked at Java and they said, oh, it's a scripting language. And they looked at Tickle and they said, oh, it's a scripting language. Gee, Sun has no idea what they're doing, right? Because they're exactly the same. Well, they're not, right? They're not the same at all. And so John wrote this paper which tried to sort of like characterize them, the differences between programming and scripting. And it wasn't a particularly successful paper because he left to do Scriptic shortly thereafter, and then Eric Schmidt left and he's doing that thing called Google now and like, whatever, right? But the activities are very different, and I'm going to argue that there is a third level of activity. So you have programming. Programming is like millions of lines of code and like huge amounts of goop involved. To give you some idea of the amount of goop, the portion of the Windows base that the PowerShell team enlists to build PowerShell is between 20 and 25 gigabytes of CRUD. Our source is, it probably fits on a floppy disk, right? It's very small, but it's all of the infrastructure, it's all of the logging and the tools and the test harness and just like this huge massive stuff and specs and spec tools and on and on and on and on, right? Programming produces a lot of artifacts. You have to manage a lot of artifacts. It becomes a very expensive process. And sometimes you can get kind of lost in the artifacts and then you end up shipping your software a little bit late. You know, it happens to the best of us, right? And then the scripting. Scripting is much more lightweight. Scripting is sort of the core of the web, much more flexible, fast release cycles, much more adaptive and that sort of thing. But still, there's a fair amount of artifacts and there's sort of like release cycles and publish to web and all that kind of stuff. At the bottom, there's shell scripting. Shell scripting, I keep telling people, the average line of a PowerShell script, the average length of a PowerShell script is 80 characters. Not like 80 lines, it's 80 characters. It's what you type on the command line. Most of it gets thrown away. Like, if you look at command lines, you're going to throw away like 99.95% of the scripts you ever write in PowerShell because you're just typing them at the command line. It's very incremental. You'll type something, you go, oh, I'm rerunning this 3 times. I should save that to a script. And then you build another script that talks to that script. And eventually you go, oh, I'm starting to build an application, and you go, maybe I should change it into something else. So CVS is a good example of this. CVS began life as a bunch of shell scripts, right, on top of RCS. Little by little, it got rewritten in C and turned into an application. Designing PowerShell, we had a set of rules. People are more important than computers. We all know this. Pragmatics win. Pragmatics defined in the context of what we were doing, right? Not pragmatics in the large. So there are things that we have done that will appall people. The next one's interesting. Innovate as little as possible. Because shells have been around for a long time, right? They've been around for 30 years, 35 years, 40 years, whatever. And so they haven't changed a lot. I mean, there's been some innovation, but not a ton, right? So we said, okay, very well understood space. How do we adapt that to Windows? Because Unix has grown up around the shell. The Unix management surface is very shell-oriented through RC files and text-based config files. They work very well together. Windows has not done that. In fact, we ran like crazy from the command line for a very long time. We're a GUI. We really are the Macintosh. So our management APIs are very API oriented, very object oriented, especially with Windows 2000. That kernel, everything is all about objects. So you can use a text-based shell, but now you're taking your objects and you're turning them into strings and then you're parsing them and all that stupid stuff, right? And you could do it in XML, but then there's that like bloat factor. So we wanted to take a shell that could work with objects. We had some good models of how this might be done in Ruby and Python and some of the stuff that had been done with Perl. So we said, okay, we're going to start with a shell, POSIX.2, standard shell. Don Terry, who was the TR for the POSIX shell spec, actually was involved in some of the early design stuff. And we're going to add objects, and then everything else comes from that, right? We will, where we run into a problem, we will borrow rather than invent if we can avoid it. And we looked at various object technologies, and .NET was, we couldn't have done it without .NET, right? The great thing about shells is that they work with text. The great thing about text is you can look at text and you can figure out what it is, right? You have a pretty good idea of what it is, right? So we needed to have that same sort of level of sort of concrete tactile access to your data, which means that you need self-describing objects. COM is not that, right? To create a self-describing COM object, you have to do a lot of work, right? So not everybody does COM, not everybody type libs and registration, and no. .NET solves a lot of that by building the metadata into the assemblies. So now everything is self-describing pretty much. So .NET rocks, almost. The objects are still being designed by programmers, which means that they're not necessarily suitable for shell consumption. And there's a bunch of other crud that we still need to deal with. We still need to deal with text. We now need to deal with a lot of XML. We need to deal with COM in this environment. We need to deal with WMI in this environment. So we have to go beyond the basic .NET stuff. And it's a shell, damn it, right? So the basic syntax, copying a file, cp foo.txt, bar.txt, not file.cp double quote foo comma blah, you know. There's nothing wrong with that. It's a good scripting model. It's what Iron Python, it's the stuff that Jim was showing on Monday. And we actually support that mode, but when you're typing at the command line, you want to have a very, very basic syntax. For production orientation, we don't want you to choose. So the way you write commands in PowerShell are written as classes. We attribute members in the class. They become the signature for your command. So it's all declarative. We extract the data, metadata from the class, and we build up a parameter representation. You don't get to choose. You do not get to choose whether it's slash or dash. The parser understands commas and all that kind of stuff. So if you ask for a collection of objects, we will take care of building the collection of objects for you. You don't have to implement parsing. It's all done by the interpreter. You build your class. You overload a couple of methods. We will call you when we want you to do some work for us. Who has ever written a shell-style interpreter? Who knows how they work, right? Is the whole the quote removal and then substitution and then parsing thing, right? It's just it's crazy. And it ends up producing these because you're having these multiple layers of parsing, you have all these micro languages, right? So you have this one language, and in variables you have the dollar, squiggly bracket, pound sign, for truncating strings in variables, dollar, paren for doing arithmetics, and there's like 6 or 8 different languages in the Corn shell. I'm probably like way low. So our goal was to keep it down to 2. So you look at a command. If it's an unadorned word, then it's some kind of command, dir, copy, whatever. If it starts with a number, if it starts with a $sign, or a few other literal signifiers, then it is an expression. So we tried to reduce the number of parsing modes down to 2. It is recursive, right? So if I have a command and I put a paren in front of one of its arguments and I'm re-entering a parse mode, so you can say echo 2 plus 2, and you will see the word 2 plus 2 come out. You say echo open paren 2 plus 2, you will get 4, right? So you're recursively entering the parse modes. Very regular canonical verbs and parameter names. Again, production-oriented scripting. If you want to get an object, then you should use the get verb. If you want to add an object, then you should use the add verb. You shouldn't use, attach or create or ram or stick or shove or whatever, right? Just use one verb. And we had actually, at one point, proposed locking it down so you could only use the canonical verbs. But we got enough pushback that there are people who are in specific domains that we weren't really all that interested in, but they were interested in us, like graphics and so on. They wanted to have their own set of verbs. So now we give guidance, and we're going to provide tools that will give, you can run an analyzer on your commandlets, and it will tell you whether you're using the right verbs or not and make alternative suggestions. This is our architecture. Why am I showing you a nasty Visio slide? Well, this is a system, not just a language. You see the parser is like the little block up there, and that's the chunk of it that is actually the language. What Jim was showing earlier this week never went through the parser, right? So there's a data flow engine, which is the pipeline processor. You insert a collection of commands in the processor and say, go. And it chugs through and executes commands and generates the data. The commands are done through a sort of a proxy class mechanism. So you can have different kinds of commands. You can have native commands, which are processes, commandlets, scripts. It's an extensible mechanism, so you could have commands written pretty much in any language. Any language that can generate a .NET class can be used to write a commandlet. We will get a session state. We'll get that a little bit later. Like a big block is session state. All these other subsystems. The type system is a huge chunk all by itself. These are all independent of the language. In fact, you could rip the language out and stick in a completely different language, and it should work, as long as it builds the right data structures, it should work just fine. At the top is the RunSpace API. This is our abstraction for execution. It's loosely based on the ADO.NET model. One of the things that it is intended to abstract is location. So when you talk to a RunSpace, the RunSpace may be in your process. It may be in a different app domain. It may be in a different process. It may be in some process running in a computer around the world. It's all abstracted. We will serialize as needed. Streaming behavior. Again, this is a key characteristic of a shell language. If you do something that's traversing your file system, you want to see results as soon as they are available, not when the last thing has been looked at. And so our model, because we're doing objects, we want to have live objects. Everything runs in process. It is single-threaded. We've had lots and lots of discussions and heated arguments, but it's single-threaded because the target audience are administrators. We're not going to tell them how to do all the locking and so forth. And most of the stuff in .NET is correctly not thread-safe, because if it was thread-safe, then you'd be paying that penalty all the time. That would be like Java 1.0 or whatever, right? Really slow I/O.
So I have a question.
Sure.
So, this streaming does that also include redirection?
Yep.
Okay, so application.
The question was, do we do redirection? Yes.
So the application developers don't really need to do anything different to support PowerShell in terms of communicating with standard out or standard in.
Not really, no.
Okay.
In fact, well, we'll look at a commandlet in a second, and you can see what they actually do. We handle the redirection. We handle a lot of stuff. That's really the only way to say it. So it tends to look a little bit like LINQ. So people go, oh, you're just like LINQ. We're not. We use much more of a continuation passing style. So A executes, saves its state. B executes, saves its state. C executes, goes back to A. It resumes its next one. They're not real continuations, but it's conceptually continuation. The flow of control is from the beginning to the end. One of the things that it lets you do is it gives you fan out, right? So you can write to standard out, you can write to standard error, you can write to, we have a couple of other streams. We want to generalize that so you could have an arbitrary fan out. Data bound from the pipeline. So when A writes an object, it isn't an anonymous object coming into B. B has a set of parameters which are of particular types. If A has properties that correspond to the parameters in that object, we will automatically map those. So you don't have the commandlet doesn't have to do any argument cracking. The binder will do that for you. This is a pathologically complicated algorithm. It's really slow. We're going to try and fix that. But it's surprisingly, people really like it. I mean, it's very difficult to understand, but it just eliminates a lot of work on the part of the programmer. Cardinality coupling, this is one of my least favorite things. So you see A pipes to B, pipes to C, and you get 3 objects out and you know you have a collection. You get 1 object out, what do you have? Do you have a collection of 1 element, or do you have a scalar? You have no idea, right? You can't tell. We could annotate everything, but quite frankly, we don't want you to know. And so we have a bunch of mechanisms where if you have a scalar, if you require a scalar and you have a collection of 1 element, we'll make it into a scalar. If you require a collection and you have a scalar, we'll wrap it in a collection. We will do all of the covariant conversions and so forth. Lambdas are important. They are not currently closures. I believe that we're going to need some form of closure. Tickle. Who knows Tickle? Right? So Tickle has, when you build a button in Tickle, what Tickle actually does is it builds a new function that is closed over the underlying data structure. This is like Tickle pervades everything. There's Python bindings and Perl bindings and Ruby bindings on Tickle. The language itself was not successful, but the model was very, very successful. And it's really all closure based. So we do need to have some notion of closure if we're going to do much more GUI programming. The lambdas, we just kind of ended up using them because we needed this ability to pass around chunks of code, and we didn't want to do evals all over the place. And creating, again, we wanted to avoid the sublanguages, so by using lambdas we avoid the sublanguages. This is what a commandlet looks like in C#. It's just a class. It derives from commandlet. It's annotated with an attribute that gives it its name, noun or verb and noun. It contains a set of public members that are also annotated with attributes. Parameter just indicates that it's a parameter. They are strongly typed because things in .NET are strongly typed. There are some additional attributes you can specify. You can say this parameter must be specified to run this command. So you say mandatory. You can, by default, parameters are only allowed to be specified on the command line. If you want it to be bound from the pipeline, then you can say allow pipeline input. You can say allow pipeline input by value or by property name. By value means that the inbound object has to exactly match, well, it has to be convertible to the type that you're expecting. By property name means that the inbound object must have a property on that object that can be converted to the parameter type. There are 3 methods you overload: begin processing, process record, end processing. All of the commands in the pipeline, the begin processing element is run, then process record in A runs, process record in B runs, process record in C runs, and then end processing in A runs, and then processing in B runs, and then processing in C runs. So it's nicely structured and you can figure out what's going on. This is what it looks like in PowerShell. Very, very similar. Again, you have the 3 begin and end clause. If that word was lambda instead of parameter, or instead of param, you'd all know exactly what it was. So here's a couple of examples. Get process gets processes, gets the current set of working processes. Where object, $underbar, it's where everybody goes, oh, it looks just like Perl. $underbar is the inbound pipeline object, where the working set is greater than 1 megabyte. That is part of the language syntax. We have quantifiers attached to values. Programmers go, what? And admins go, yay! Like literally, I mean, the first time we talked about this at MMS, the audience cheered. This is something that admins run into all the time. They are working with these large quantities, and typing a lot of zeros sucks. So again, this is one of the things. Depending on your audience, little things mean a lot. Something I haven't talked about yet. You may have noticed that command didn't do any formatting, right? You can't say like ls-l or whatever, because it doesn't do any formatting. It's up to the system to do the formatting. There is an entire formatting subsystem that will render your objects. So what I'm saying, get process, where something has a working set greater than 1 megabyte, formatted as a table with 2 properties, name and working set. The next example, same basic thing, but now I want to sort it in descending order. By default, it's sorting by name. I want to sort it in descending order by working set. I don't have to say sort $3, I don't have to do any of the indexing. It's objects. It knows what the properties are. And then the last example is, well, you know, that thing about typing in 80 characters, well, you got to have shortcuts, right? So we have a canonical set of aliases for commands, GPS for get process, question mark for where object. This was the subject of much debate on the beta place list. People wanted, they didn't want to type it at all, right? They wanted the command to figure out whether it was doing map or filter. And in the end, we said, no, okay, filter is question mark and map is percent, because percent is kind of like mod and it sort of almost, it starts with M and makes sense. I don't know, I'm making stuff up. And, you know, sort just shortens to sort, and format table. So you can get a fairly pithy syntax. The PowerShell type system, under slide at the beginning of the session, random data, you know, data is not equal to object, it's random guck in the admin world, right? It's like whatever sludge is lying around out of my application, out of your application, out of that, you know, stuff on there, over there, some mail messages, it's random crud, and we want to canonicalize it so that you can work with it like objects. So the lofty goal, it is a generalization of the object relational problem. I want to take any arbitrary piece of data and surface it as an object. We're doing this by extending the .NET type system. So if it's a .NET type, that's great. If it isn't, then we'll use .NET and reflection and a few other things to make it look like a type. PowerShell is type promiscuous. We'll get together with anybody, right? So it is type promiscuous, but it is fairly careful. So if you require an int and you have a string that looks exactly like an int, we'll make it an int. If you have a string that has crap in it, we won't do the JavaScript parse in thing and go, oh, I'll take the part of it that looks like a number and we'll ignore the rest, right? No, it's an invalid conversion. We won't do lossy conversions for some definition of lossy. So we'll happily convert a float to an int as long as you don't lose any value. If you have a decimal involved, everything stays decimal. We figure if you're using decimal, you want the precision. I don't care if you could represent it as a float. If you're going to lose precision, too bad. Decimals stay as decimals. And it is a user-centric layered type system. At the bottom, you have the real representation of the objects, which were designed by professional programmers and are therefore wonderful. We have a variety of objects, so .NET, COM, WMI, ADSI, XML, ADO, data tables, blah, blah, blah. In the middle layer, we have adapters that take each of these data types and surface them in more or less the same way. So the .NET adapter just proxies the properties and the methods. WMI and COM do a little bit more work. ADSI does more work. ADSI is Active Directory, LDAP stuff. XML, we do a lot of work, right? We use the XML DOM object to surface it as, it's kind of like what the VB stuff does, but nothing like what, it kind of looks like what the VB guys do, but is not at all like what the VB guys are doing. And then at the top layer, we have a synthetic object layer. So I can take system.ArrayList, and I can add a member to the ArrayList class. I can instantiate a particular instance of an ArrayList, and then I can add a member to that instance of an ArrayList. So very sort of JavaScript-y, I can do anything I want to anything. There's a way to get around the extension layer, which I may show. But this allows us to do things like rationalize a type system. So if they were all designed by everybody and there was an overall committee specifying names, which, by the way, is what WMI is, right? WMI is this like, huge specification, has canonical names and everything. But you get like a file info object that has a name. I have a process object that has a process name. Why? What? So you don't know, right? There are key properties that are the same on all these objects that have like completely different names. How can I write a script that works universally with all of these things? And that's what we do with the type layer. You can do aliasing on properties. You can add new properties. You can wrap existing properties. So if you wanted to log every time somebody called toString, you could override toString, call the toString on the enclosed object as opposed to the base object. This is all done through a wrapper. Wrapping has some of the problems that John alluded to. You have this problem of dual identities. But, well, it would be nice to have a better solution, but we haven't come up with one. So extension methods. We'll get to the demos in a second. So we have something called get method. or get member. Get member will work on any type. You can pass it a .NET type and it will tell you what the members are. You can pass it an XML object and it will tell you what the members are. You can pass it a COM object and it will tell you what the members are. So it's kind of like dir in Python. Canonicalization. So 1, 2, 3. Tuple operator builds an array. Arrays have, in .NET, length is length. But all the collections have count. We want to have it have count, so we add a synthetic property count, which is an alias to a length. And then I went and added, in my example, I have a bunch of sequence operator kind of thingies. So you have ls, and then produces a collection of file info objects, and from that I say drop things that match PS1, so it converts those things to strings and throws those away. I want to keep the ones that say VB, so I keep. And then I do an if and pass it a lambda that says, okay, with the name's length is greater than 10, I want to keep those. And then I want to extract the one property, which is the length, and I want to sum the whole thing, and that gives me a number in the end. Right? So these are all synthetic properties. None of them exist in collections on .NET. But it gives you a very pithy way of expressing calculations. Session state. Session state's one of the big subsystems we talked about. It is a place to put my stuff. George Carlin's routine, my stuff, your, you know what. And it holds everything, right? It holds the world. So it holds all the normal programming languagey things, variables, functions. It holds the environment. It holds the file system. So it has file system drives. It holds the registry. It holds the certificate store. In the future, it will hold AD, it will hold WMI, it will hold anything you want to do. We have a couple of examples. We have a session state provider for a SQL database. So you can mount your database as a drive, and then you can CD into it, and you can do a dir, and you'll see the tables. You can CD into the tables, you can do a dir, and you'll see all the columns. Right? Any data structure that can be surfaced in a navigable way can be adapted by writing one of these provider models. It is dynamically scoped. This is where everybody goes, oh my God, you're an idiot. It is dynamically scoped because we're writing a shell, right? Shells have for 30 years been dynamically scoped because they're based on a process model. So the parent's environment is copied into the child process. When the child modifies something, it modifies it in the child process, not in the parent. We have emulated those semantics within one process. When you inherit all of your parents' variables and drives and whatever, you can't, by default you can't modify them, but there are ways of doing that. You can also modify stuff in the global scope. And we played around with a bunch of different models.
So I was actually going to ask about, talk about CD into a database.
Mm-hmm. So the question is, do we provide providers for arbitrary crap like that explore surfaces like zip files? We don't, but we're happy to talk to anybody who does. Right? One of the things that, as PowerShell went through its growing pains, is we had grand plans. We were going to, do everything. Well, guess what? We're a small team. We can't do everything. And we can't convince anybody else to do anything for us until we ship, and we're not shipping yet, so we have fairly limited coverage. In fact, this is one of the things that drove the .NET stuff. Right? We need to have enough surface area covered to be effective and useful in version 1. But we can't get everybody to write all this stuff, so what can we do? Well, if we make .NET directly available, then you can get at everything. So that's wonderful, and then people will start to use it, and then they'll do all the stuff that we want them to do. Right? It helps if you suck up. Security. Got to have a security slide. This week, if you look for PowerShell, you will see that the number one topic is the CBiz virus. This is this August's virus as opposed to last August's virus. Last August, a virus was written, well, they're calling it a PowerShell virus. What it actually is a virus written in PowerShell. It's like calling it an Intel assembler virus or a Python virus. It is not an attack on PowerShell. It is an attack on Windows written in PowerShell. And last year, this kid in Australia wrote it. He's written the same code. He actually wrote it in x86 version. He's written a Python version. He's written a Ruby version. Last year he did a Monad version, and this year he's done a PowerShell version. And the press has picked it up every time. This time they're a little better. They are using the inflammatory headline, and then they tell you that there's nothing to worry about in the article. I mean, they're actually accurate in the article, but the headline sells papers. So the other nice thing is that when this happened last year, of course, F-Secure picked it up. They forwarded it to everybody. It ended up on Slashdot like 3 days in a row, right? Like, because internally we hadn't talked to the Microsoft Security Response Center, and so they said, oh well, first off, Monad virus got cast as the first Vista virus. They went to, that was when we were like doing all the Vista stuff. And they went to the Security Response Center. The Security Response Center said, Monad? I've never heard of that. It's not in Vista, so what are you talking about? Which immediately got back to the press, and they said, oh, Monad's been canceled, and there's another thing that's been canceled out of Vista. So this produced like day 1 virus, day 2 canceled, day 3 Microsoft are idiots. It was over and over again in Slashdot. The nice thing about Slashdot is that it was a very intelligent conversation. The people, other than the people that's like Microsoft sucks, there's always that group of people. But most of the people went and they looked and they said, wow, F-Secure are idiots. Right? That they had been very irresponsible in not verifying what had actually happened. So that was nice. We were really very pleased with the way the community handled that one, and they're actually handling this one fairly well. But I've been watching. I mean, the thing came out on Sunday, and it hit the blogs on Monday, and it like accelerated, and it hit CNET yesterday, and now it's going to hit like the Washington Post or whatever. It's very irritating. Anyway, we have a whole bunch of features that prevent this, right? So the current thing is being distributed by Kazaa. Drops a disk file on your disk. If you drop a PowerShell file on your disk and you double click on it, you'll get Notepad, because that's how we bind the default association. We do not run PowerShell scripts by default. So you'll get this Notepad popping up going, oh look, I've got a virus. Yay.
So question, can I, on a command line, can I run type the name of the shell and press enter? What will happen?
If you PowerShell.exe, it will launch.
No.
If you type foo.ps1, if you're in PowerShell, it will run. If you're in command.exe, you'll get Notepad. Right. So you can say PowerShell-C, foo.ps1, and it will run. But we are not creating a file association by default for exactly this reason. Number 2, we don't execute out of the current directory. So the cd into this directory and run ipconfig, and then you end up running a virus file. We don't do that. And command.exe does execute out of the current directory by default. We decided that bad. Don't do that.
So when in Windows, maybe my lack of knowledge, when you double click on a program, maybe on the desktop, can you configure it so that it runs under PowerShell? Will it run under command?
So when you double click, it goes to the registry where there are a set of file associations that say how the program should. So this is the application to use. Basically, there's actually a system call that says, give me the application associated with this extension. By default, when you click on it, it'll run. What we do is we say the default application for the system to use to run PowerShell is actually notepad.exe. You can create a shortcut on your desktop that does PowerShell.exe-c name of. So you can create a shortcut to do it. But just dropping a file on your desktop won't do it, right? Just the I love you thing won't do it, because we won't run them by default. The next thing that we won't do by default, so we use an execution policy. We check the execution policy before running a script. If the default execution policy is no execution of scripts. So you can use PowerShell interactively, but you cannot run any scripts. If you try and run a script, it will say no. There is an all signed execution policy, where all scripts must be signed by a signing authority. The minimum recommended policy is remote signed. So anything, if you download a file from Explorer, if you download a file from IE, it's marked as coming from the Internet Zone, and in remote sign, we require it to be signed. I mean, you can make a copy of it or whatever, open it up and save it in a different file, and then it'll work fine, or you can actually sign it. This execution policy is controlled by group policy, which means that in an enterprise organization, the administrators can choose and push this policy out to arbitrary machines. So they get to choose. And they're pushing the scripts out there anyway, so they might as well push the policy. And then the last thing is script signing. Obviously, if you have execution policy that requires signing, you have to do script signing. But over and above the script signing thing, we also verify the signature. So we do an additional check. So if you see something that looks like a signature but is invalid, then we won't run the file, because it's people will look at it and go, oh, look, it's signed, it's cool, I'll run it, right? So we want to. And the other thing is the signature is like huge, and so you have the attacks where people stick way down in the middle of the signature. They stick a little bit of script code that does something evil. So you look at the top, you go, oh, that looks safe, and it's all signed, right? No. So we actually, Michael Howard sent mail around saying that we're a little anal about security, but Microsoft has not had a good history with scripting languages. Netscape started it. They turned on scripting in their newsreader for about a week, and then they realized it was a very bad idea. But we saw them and said we should do the scripting thing in mail and stuff too, and didn't figure out the bad idea until a little while later. So, but we're learning, right? We're not complete morons. Some example, basic processing. That's where I'm going to try and go over to demos. So we'll just select let it page back in. So what this is doing is recursing through the Windows installation directory, looking for DLLs that are larger than a certain size. That nasty black thing in the middle, this is again something that's an aspect of the shell environment. We have this concept of non-terminating errors. In a traditional programming language, as soon as you have an error, you stop, right? And then you're done. What we do is we write an error to standard output, just like a shell. We set $? To be false, saying that this command failed, and then we continue on, right? So we terminate that set of processing. That object is no longer being processed in the pipeline, but we continue on with the next object. Of course, there are going to be times when you don't want this to happen, and so we have an execution action policy mechanism where basically the default is continue. You run into an error, continue on. You can change it to be stop. You run into an error, the first error you hit, you stop. You can also say, I don't care about errors at all, and you can set it to silent continue, and it will continue on. We keep a running log in a circular buffer of all of the errors that have occurred. So that was the error that you saw rolling by on the screen. And that was the exception. And that's the stack trace, right? So that's the .NET stack trace that caused that exception. So you're sitting in a scripting language and you can debug down into the bowels of .NET. And that it's just automatic. Now if you want, but it keeps a circular buffer. It's a finite number of errors. If you want to keep all of the errors, then there is a standard parameter to all commands called error variable, and it will accumulate all of them and leave them in that variable. So you can capture all of the errors. You can capture the errors for a specific element in the pipeline. So you have pretty good error tracking capabilities. On top of that basic error model, we do have an exception handling model. It's vaguely similar to what the Perl 6 people are doing with the trap statement. If an error occurs, regardless of execution policy, control will transfer to a trap statement that is in scope with, if there's one in scope, it'll transfer there. That statement gets to choose, right? So it can do arbitrary stuff. It's essentially a lambda. And it gets to choose whether you continue or not, right? So you can say, yeah, this error was bad, stop. Or it can say, this error was not so good, report it, but continue on. Or it has the option of saying, I don't even care, just keep going, right? So it's up to the trap handler to control the flow of error handling.
And you have internal variables that represent things like return code from an application, right?
Yep. So there's that one, and then Oops. There. So that's the return code from that execution of command.exe.
Besides exit, besides this log of errors,
Uh-huh.
is there a log of informational messages, warnings, or things of that nature that can be sent from applications out into the shell?
There are a world of such things. So one of the things, this technology is the base of the Exchange 2007 management console. They have certain fairly stringent requirements around logging and tracing and so forth. Commandlets are bundled into collections called snap-ins. On a snap-in, you can say, log the snot out of everything. So it will log every object that's processed. It will log the command line. It will, it just logs like crazy, right? George wrote all that stuff, right, George? So you get very detailed logging isolated to a particular set of commands. People often ask, what's the difference between, like, why are you doing commandlets? Why aren't you just doing methods? The parameter stuff is a big chunk of it. The logging is another big chunk of it, right? So I can say for the Exchange snap-ins, log the crap out of everything that happens that touches those snap-ins. So we'll do this is our grep equivalent. I actually have it aliased to grep. Right, so I just searched through all of that. A little bit interesting is it's not returning strings. It returns information objects. So it has the file name that it found it. It has the line number that it found it. It has the text of the line that matched. It has the various elements of the condition, the pattern that was matched, and so forth. And then the formatting and output system takes this object and renders it in something that looks like the output of grep. Here's a fun one. Is anybody going to, I know George knows what this is going to do. So what this is doing is, so I have a string VMS, right? So VMS turns into WinNT. Yes?
I know this might seem a little trivial, but is it possible to make a prompt, keyboard, input, and the output in 3 different colors? Because I've always wanted that.
Yeah. Yes and no. Yes, it is. It requires a little tweaking. One of the things, so our formatting and outputting system does not currently support color annotations. So internally it builds an XML kind of representation to do the rendering. We didn't get the color stuff in. We want to add that later. You can do it through direct console calls.
No, I don't mean as part of the individual scripts. I mean as just an application of the set.
Right. So I mean, you can do that. Well, one of the things is like the prompt, for example, right? My prompt is setting the path up there. It's a function, right? It can do anything you want it to do. It can like draw Mandelbrot patterns. And we're doing tab completion here, right? So I did last error. So I tab complete on that. Right. Right. So it does tab completion on methods. I saw Jim doing that, so I had to steal it. Tab completion is so the tab completion is actually done as a script too, so you can change it and do anything you want.
Can I host the shell elsewhere?
Sure, absolutely. I'm going to jump ahead because Jim is waving the "you're going to run out of time" thing. Well, let's go through a couple more examples quickly. Oh, this is for Eric, right? Right. So there's the canonical Haskell quicksort, right? There's the same thing in PowerShell. So we don't have the pattern matching stuff, so I had to use the head. So $P get the pivot is the head, $L is the tail. It's just like Python, Perl, and so forth. If the tail is empty, then just return the pivot. Otherwise, take the elements out of the tail that are smaller than the pivot, sort them, add the pivot, and then sort the ones that are greater. So there you go. Functional programming on the shell. Yes. This is a WinForms example. I stole this directly from Jim. This comes out of the Python examples. Of course, I'm launching it from a console window, so you can never see it, right? It always appears behind, but it's exactly the same thing, right? So it's just creating a form and then binding a callback very quickly. So this is the code. I have a small script that I dot source, just like in the Corn shell, and it defines a couple of handy functions. Form creates an object in the WinForms space. I pass it a hash table. It iterates over the members of the hash table and binds those elements. So I give a lambda to click. I bind, so the click handler for the form is bound to this lambda. The lambda creates an instance of a label, sets text, sets auto size, sets the location, and then sets the font, right? And then at the bottom I do the application run. So it's tweaked a little bit from the Iron Python, but essentially the same. Jim has better UI thread handling than I do. This is kind of cool. So at the top, this is the XML literal stuff, right? I pass it a string, I cast it to XML, and I get back an XML DOM object that I can then like drift through. This becomes much more fun when you put it into a function. So this is the canonical RSS reader that everybody else has shown. Let's see how well the net is working today. Poof! Magic. So these are the top list of things off of our blog. So I create an instance of a web client object. I download the string, take the string, cast it to XML, dot through the bits till I get what I want, and then I use a select object to extract the two properties out of all the crap that's in the XML object that I really care about, and then the system automatically renders them as a nice chunk of text. So that's kind of fun. That example shows up a lot. As a COM example, that's kind of icky, so we'll do equals new object. So object creation in PowerShell is done through a library function, through a commandlet new object. See if I can get it to actually work. Okay, so I created the Excel COM application, but nobody can see it until I do visible equals, right? Poof, and it appears magically. And now it's gone behind again. E dot add, and there it is. So I've added a workbook, right? And it annoyingly returns a value. This is something that we run into a lot. When you evaluate an expression in PowerShell, it gets written to the standard output immediately, like a normal shell would. So you find all these places in .NET that are returning objects, and COM too, that are returning objects that are like, why is it doing that? ArrayList.add, why is it returning me the number of objects in the ArrayList? I couldn't care. So there's a bunch of places where you have to void or cast a void or redirect standard output to null. One of the things in the COM example here is I'm getting a let crap, and then I have a little function that formats things as a fragment of HTML, and then down here I have a here string, which should be familiar to the Perl users, and I do substitution in the here string, so it just generates an XML object redirected to $e and dig.rss, and then I just launch that, and it runs the browser, which is all very exciting. Calling VBScript. So VBScript is the historic admin scripting language. It's still like very, very widely used. It makes sense for us to be able to work with VBScript. So thanks to COM, we create an instance of the script control. I add some code. I get the code object back. So each of the functions in the code object is exposed as a method on this thing on $VB. I call it. It gives me the length. And then I do a string expansion in here, add two numbers together. So we can get decent integration with VBScript or any active script. So I think it's the same thing in JavaScript. We get the same kind of integration. It's not wonderful. Jim talked about somebody talked about some of the COM problems earlier. COM to .NET interop is not all that we would like it to be. There are cases where you have to work fairly hard. You may not have the type library. It may not be registered, and so on. WMI. WMI is this wonderful source of information that nobody knows about. Right? So if I want to find out all about my disks, I will do this. I will try and tab back to my window. So let's find out all about my logical drives, right? So there, WMI query, right? I don't have to do anything. If you look at the code in VB to do this, there's like a whole bunch of preamble before you can ask anything. .NET just kind of, PowerShell simplifies that a great deal. This is a little weird. WMI exposes itself as a database. It has a query language called, surprisingly, WQL. When we showed this at MMS this year, people went, like, get WMI objects cool, but where's the rest of it? And so we came back from the show and we said, no, we better add some more stuff. We've added a bunch of these type shortcuts. So one of the things you can do is WMI searcher is a type alias for one of the classes. You take your query string, cast it to one of these instances, and do .get, and you've just done a WMI query, which you can then iterate over and print stuff out and things like that. What this is doing, by the way, is getting the calc process and then just killing it off. One of our other bloggers, getting processes and killing them is a very popular PowerShell demonstration. You can do it with native processes, and you can do it with .NET methods, and you can do it with commandlets, and you can do it with WMI, and you can do it with commenting. So this guy wrote, like 50 ways to kill a process. Out of process remoting, I'm not going to talk about this a whole lot. We don't actually have the remoting stuff in place. We have the serialization. So when I say PowerShell squiggly bracket, the Lambda is being executed in a child process instead of being executed in the current process. It does a shallow serialization, a shallow fuzzy serialization. We serialize like 18 types accurately, and everything else goes into a property bag. Why did we do this silly thing? Because we were working in a remote, in an admin environment where machines are on different versions. You may not have this type on that machine. We need to be able to talk to all of the machines and reliably get data back. And so we shoot for an adequate lowest common denominator. The previous alternative is SSH, right? Where you get a bunch of strings back. Now you at least get structure back. And a lot of stuff just works, right? Because we preserve some notion of the original type. So if I'm doing an LS on a remote box, it'll get printed out like I've done it locally because it knows the type that it formerly was. If you're like a Guys and Dolls fan, it's like throwing dice. You have to use our stuff because it gets serialized back into these PS object things. Once Jim's done his magic, right? That was what Jim was talking about. Is VB has a notion of dynamic objects, and we have a notion of dynamic objects, and IronPython has a notion of dynamic objects, and Ruby has a notion of dynamic objects. So one of the things that we're trying to do is getting everybody to talk. Okay, once we have a canonical representation for dynamic objects, whether it's a set of interfaces or whatever, the world will be wonderful. Like it'll all be great. Wrap up. Okay. Inline IL, same kind of deal that John was showing earlier. So you can do inline assembler in a shell script if you want to be really demented. I was going to show the compiler, but one thing I did want to show is this is fairly important. It takes a second to come up. This is MMC 3.0. This is the new version of MMC. It allows you to write managed code snap-ins. What I've done here, this is a prototype, but this is the future, right? Is the ability to do management through snap-ins. Exchange is doing it today. The entire management surface of Exchange 2007, a $1 billion business all by themselves, actually they're probably a lot more than that, is done through PowerShell commandlets. And the reason they do that is they want to have a single entry point. And the biggest complaint that they got in Exchange 2003 from the management perspective was no command line, right? So they said, okay, we're going to do a command line, and then everything else will be based on the command line. Because we do objects, it's possible to do a decent command line. You don't have to do all the data parsing. So what I've done here is, the model is, this is essentially kind of like a DSN, right? So this is a query. It produces a bunch of data that gets stuck there. When I select an element of data, there's a bunch of actions associated with the data. So this is sort of the model in MMC. There's a scope node and a result pane. They have a variety, like a simple. So I've just run a script and it's generated. It's done, iterated through a collection of numbers and generated some asterisks. I've just queried the system for services. This is that blog thing again, right? So I've grabbed again, it runs a shell, it goes out and grabs the blogs, and then I can show in browser. And this is creating a bunch of child nodes. And eventually it will show up there. So this is the future, right? This is where we're going to do. What we're going to do, GUI on top of command line. We've talked to a lot of people. It has resonated very, very strongly with people. So the days of having to go clicky to manage your Windows box is over, right? PowerShell and MMC and this thing that we're calling Aspen, that's the future. We've talked about it a little bit. The other thing is, and as Jim demonstrated, if you don't like PowerShell, and there are going to be lots of people who don't like it, you can, because it's .NET, you can do it in Ruby, and you can do it in Python, and we can't do it as well in C# because of the static typing. Probably do it in F#, so you can write really cool functional management. I really want to look at F#. It looks really cool. And then we'll wrap up very quickly because I'm way over. Where's my slides? There we go. It's community resources. Microsoft.com/PowerShell is the link to all things wonderful. The newsgroup name is wrong because they kicked us out of that because we... Oh, yeah, sure. Except it goes right to the...
Shift F5.
Yeah. I don't do PowerPoint much. A quick tour of the world.
So while you're doing that,
Yeah. Man.
So your default output renderer thingy
Mhm.
renders out to the console, right?
Yeah.
Can I kind of like
There you go.
replace that via config?
Yeah, you can. So it's the default renderer. There's a hosting model, right? You create a host, you pass it a host interface object. I call back on that to do the rendering, right? The APIs on that thing are really console-centric. It has like a rectangle and so forth. I don't think it's particularly useful. I mean, if you want to write into a rectangle of character, sure, that's fine. But you can replace the whole thing, right? You can inject new commandlets. So it runs a commandlet called outDefault. We haven't surfaced the markup language yet. It's complicated in Baroque. It's on the list. There's a lot of things in here. There are a lot of extension points, the ability to add new commands and so forth. We haven't surfaced those yet because we had problems with documentation. We couldn't get enough documenters. We can't get enough testers. We're very test bound. We have like 60, 70,000 test cases in our test suite. The check-in suite is like 20,000 test cases. It's probably more like 300,000 test cases. So resources. PowerShell, they kicked us out of the news group because we were totally dominating all the normal admin stuff. Eric?
Yes, sir. Why do you need to use passports to download PowerShell? Try your examples because
So remember that 100,000 people, or like the 100,000 people who downloaded, they downloaded it with passport accounts, okay? I have no idea how many people who have actually, like, because it's being recirculated and, like people have made copies and stuff. So this was marketing's idea, not mine, don't blame me, right? Talk to Scott Ottaway. They wanted to track the level of interest, right? That was very important.
Is this list of links somewhere in the distribution?
The basic, this thing has the important. The Microsoft.com PowerShell has a link to the blog. The blog has links to all kinds of other stuff. The news group is very good. The MVP, we have a great community. The MVPs have been very, very active. They're almost self-supporting now, despite the fact that we're not a shipping product. There are a bunch of books coming out. This book was released in December of last year, which is insane, and it's really out of date now because it was released on one of the early betas. This is my book. It's coming out in November. This is Andrew Watt's book. It's coming out in November. And this is Don Jones' book from Sapien, which is coming out in November. I have to finish mine, so once I'm done, I have to go on and do some writing. There are 2 more books coming that I'm aware of. One from Jim Truer. Jim Truer is my peer. He's the PM on the language. So he's the other guy that you have to blame. And then Lee Holmes. is a very active blogger. He's a member of our team. He has a great demo that I didn't show you where he does interop to a Win32 API from PowerShell, which is just absolutely outrageous. It does a P invoke from PowerShell. It's just really weird. And then Scott Hanselman has this podcast, which is extremely entertaining because he's always a lot of fun. And so that's it. PowerShell is wonderful. We're available down level to Windows XP and Server 2003 at the end of this year. We're being shipped through Windows Update, so it will appear as an optional update. RC1 is available now. RC2 should be available real soon now. And we're hiring. We're looking for developers, so if you know anybody who's interested in working on the PowerShell team, please send them my way. Thank you very much, and thank you for not leaving.